one important application that illustrates the interaction between a moving charge, in this case an electron, and a magnetic field is what we call the cathode ray tube. The cathode ray tube is the basis of the TVs that have been used during the 20th century and the beginning of the 21st century. Okay, there is something wrong with this picture here, so I'm going to skip it for a second, show you a video, and then we'll go back to this. Okay, let me go to the videos. This is one. Okay, what we have here is what we call Crookes tube. Okay, let me go back and spell it. Crookes tube. In this case, the tube is represented here. What we have is some type of power supply that's going to subject two ends of the tube. One of them is called a cathode and one of them is an anode, to a high voltage. Because of that high voltage, electrons are going to be able to flow from the cathode to the anode. Now there is some kind of cardboard or a piece of material in the back here, as you see here, that's placed, and then the sheet is covered with fluorescent material. Remember, fluorescent material is material that made up of atoms that get excited to a higher energy level, and then once they go back to their initial state, they emit light. So the electrons here, when they are moving in the tube, they are going to excite atoms in the fluorescent material, and these atoms are going to emit light. By emitting light, they are going to show us essentially a trace of the path of the electrons. Otherwise, we will not be able to see the electrons moving in this tube. That's the idea of the tube. Now let's go back to the video. So this is what we see. You notice the plate here is in the back. It has a layer of fluorescent material in it. And when we have a magnet close to the tube, we see the electron being bent that way. Okay, let's play it. I'm playing it in slow motion. Okay, actually, let me move it back a little bit. Notice here that without the effect of a magnet, the electrons move in a straight beam. The minute we approach the magnet, they are deflected. Now, the idea here, what we want out of this, is to figure out the force acting, the direction of the force acting on the electrons. Now, as you notice here, we have the north pole of the magnet towards us and the south pole in the other side of the tube. Now, under this configuration, the magnetic field lines are going to move from the north pole towards the south pole, which means they are going to be perpendicular to the screen, into the screen. If we use the right-hand rule, our thumb should be opposite to the direction of motion of the electrons. Remember, because they are negative charges, so it should be opposite to the direction of motion, as opposed to for positive charges where it is in the same direction as the direction of the velocity. So opposite to the direction of motion of the electrons, here is the cathode is in this side, the anode is in the opposite side, so the electrons are moving from left to right. So our thumb should be pointing towards the left. Our fingers, representing the direction of the magnetic field, should be pointing perpendicular to the screen, into the screen. And you notice that way our palm is pointing downwards towards the bottom of the screen. And that's the way we see the electrons deflected. Deflected towards the bottom of the screen. And then they move. This is another video showing the same thing. Okay, I have it in slow motion. Okay. Here what you notice, you had the North Pole, that's represented in red in this case, and we have the same thing. The cathode, where the electrons originate, is on the left side, the anode is on the right side. Now, as you notice, when the North Pole is towards us, the electron beam is bent downwards. Okay, now here, let it continue playing. Notice here when we have the reverse, it's not very visible, but you notice here the electron beam is bent upwards when the South Pole is towards us. Again, now, if we use the right-hand rule, our thumb should still point towards the left of the screen, but our fingers should be pointing perpendicular to the screen, but towards us. To be able to do that, our palm has to point up towards the top of the screen. And that's the way we see the electrons are being deflected. Okay, going back to this picture. So now what's wrong with this picture? Okay, I believe the labeling of the magnets are not really correct in this case. If you notice, here the south is towards us. The cathode in this case is to the right of the screen. So if we have our thumb pointing towards the right, and then our fingers should be pointing outside of the screen. The force then, or our palm, should be pointing downwards, not upwards, if this labeling is correct.